G'day cobbers, welcome back to the bush. In this episode of Lock Your Hubs 4-wheel driving, we're going to be checking out fridges and how to make the fridge you already have work better in the back of your 4-wheel drive. Using a step-up transformer to see if the voltage does anything, and also where the fridge covers make a difference. So, let's get into it. So the first thing I thought I'd check out was whether voltage made a difference. Now, when your car's sitting there in the car park or at camp, the battery is sitting on usually around about 12.6, 12.8 volt or thereabouts. And when your car's running, it could be up to 14 volts or maybe even a little bit over. So does that make a difference to the performance when you're parked up at camp overnight of your fridge? So what I did was I got my trusty step-up converter. Now this is the 13.8 volt model. I'll put the model number below in the description. And what I did was I connected the battery through the step-up converter, so regardless of what the battery was putting out, the fridge would see 14 volts or thereabouts. And we did it with a temperature data logger, so I was checking out what the ambient temperature was around the fridge, inside the fridge with 20 litres of water, and inside the freezer with 10 litres of water on just battery and using the step-up converter. And here are the results. So as you can see, there's a substantial difference in between the performance of that on the battery and the step up. So here's the line for the performance of the freezer on the step up, and here's the line for the performance of the freezer on the battery. Now, there wasn't a great deal of difference between the two pieces. Minus 6.5 with the step up and minus 5.2 with the battery only. But we did it in more than 2.5 hours faster. And with the fridge, you can see on the step up, we're actually reaching hysteria here. And what that means is the fridge has reached a minimum temperature, it turns off and then turns back on again. But with the fridge on battery, we didn't actually reach that temperature. So we're getting a substantial increase in performance with a step up, just like we did with a Travel Buddy or a Road Chef 12 volt oven. Unbelievable. I know what I'll be using in my fridge from now on. Now, both these tests were conducted over a 12-hour period, and both had an ambient of roughly about 12 degrees Celsius in a locked spare bedroom, so there was no interference and not a lot of temperature variation. And there was 20 litres in the fridge on each test and 10 litres in the freezer. So they're definitely comparable. But what about the extra battery capacity we use? I mean, there's no free lunch, is there? So let's check that out. And here we go. Yes, unfortunately, there's no free lunch. So we used 11% more of our battery reserves with a step up than we did on plain battery. 37.94 versus 34.11. So it's a little bit more battery. Now, if you were to be moving day to day with your vehicle and you're only to be parking up overnight and you had your standard 105 amp hour AGM battery, as a lot of people do, there's going to be a negligible amount of difference. So it won't make any difference to your average 4-wheel drive setup. So the next thing I investigated was whether a full fridge is more efficient and uses less electricity than a partially filled fridge. Now the first test was 20 litres of water into the fridge side and 10 litres of water into the freezer side. So I took 10 litres out. So we had 2/3 to fill, and I did exactly the same test on a consistent 14 volts. And here are the results. So both of these tests were done at roughly about the same ambient temperature, again over 12 hours. And you can see that there isn't a great deal of difference in between the two, especially in the performance of the freezer. So with our partially filled freezer, we reached minus 6.9 in 7 hours and 28 minutes. And our fully filled freezer, with the extra 10 litres of water in the fridge section, minus 6.5, so nothing in it there, and slightly quicker in 7 hours and 6 minutes. So yes, it's slightly more efficient. And here we can see our full fridge reaching hysterious and our partially filled fridge reaching hysterious again. Now, one thing interesting to note is that while we can see Hysterius in the fridge turning on and turning off, in the freezer section, in this graph and the previous graph, we can see it reaching our minimum temperature down the bottom here where the peaks are and turning off, and then it seems to maintain temperature without actually turning back on again, which has got me a little confused. Is it because it's designed that way, or are we not able to dissipate the heat that the fridge is generating to turn the thing back on? I might have to look into that a little further, and we will further down the track, so don't miss out on that one. But before we do that, let's check out the current. Now, your fridge manufacturers will tell you that a fully filled fridge is more efficient, and they're right. So over the 12 hours, we used 39 amp hours of battery capacity with our partially filled fridge and nearly 38 with our fully filled fridge. But it's only 3%, so there's nothing in it. So whilst, yes, it is more efficient, it's not a lot more efficient. It's not even a fair bit more efficient. It's next to nothing more efficient. So whilst it's a decent idea to keep a full fridge, it doesn't really matter too much. So there's next to nothing in it. 3% in between a fully filled fridge and a partially filled fridge. Yes, it is more efficient, but by next to nothing. You're not even going to notice it on your battery performance over 12 hours. Next thing I'd like to check out would be the covers. These things for your average fridge cost multiple hundreds of dollars. You'd want them to be giving you a bit extra performance, and that's what the fridge companies tell us. But do they? So back to 20 litres in the fridge section, 10 litres in the freezer section, 14 volts at the input, same ambient temperature of around about 12 degrees, so the same sort of conditions you get in the back of your four-wheel drive overnight. And we did exactly the same test, cover on, cover off, and here are the results. This one absolutely had me amazed and befuddled, that much that I actually conducted the test 3 times. I just couldn't believe the results I was getting. So here is the curve for the freezer without the cover on, and here is the result for the freezer with the cover on. Now, the cover is supposed to provide extra insulation so your fridge performs better. If that were the case, these two curves would be reversed, and they're not. We reached a lower maximum temperature or minimum temperature of minus 9.8 in 5 hours and 50, and for the freezer with the cover on, again minus 6.9 in 7 hours and 20 minutes. It's an hour and a half behind the two peaks. We lost substantial efficiency by putting the cover on. Now, the only thing I can think of that did this result possibly was the fact that the fridge was unable to get rid of the heat it was generating. And it looks like, well, it is, the cover is stopping the heat from coming out of the fridge. And you can see here that the fridge is actually turning on and off in the freezer section. We're going in up and down here, which is Hysterius, whereas here the freezer turns off and it doesn't dissipate the heat enough to turn back on. So at ambient temperatures of around 12 degrees, which you're commonly experiencing in the back of a four-wheel drive at night time when you're asleep in your swagger tent, the freezer and fridge aren't operating as well as they could do because of the cover you've paid extra money on to put over your fridge to increase the efficiency. It turns out it's doing exactly the opposite. It's costing you money and it's costing you efficiency of your fridge. Unbelievable. That's why I did this test 3 times. I could not believe it on the first time. I thought, oh, I've obviously buggered something up. And then the second time I thought, maybe I haven't buggered something up. And then the third time I thought, no, it's definitely blocking in the heat. Well, that's what I'm thinking at the moment. So we'll get to, is it blocking in the heat in a second? But let's have a look at the current consumption. And here's the current consumption. So 39.04 with the cover, and without the cover, 38.9. So only 1% within cooee of each other. So next to nothing there, but our performance was substantially worse with the cover on. I wouldn't have predicted that. It has me absolutely befuddled. And here's the filthy culprit. The transit bag for the 75 litre combi, $285. Well, that's a small consolation. At least we're not burning through extra battery, even if we are getting worse performance. So I thought to myself, why are we getting worse performance? The only thing I could think of was the mesh covering the vents on the fridge bag cover was stopping it from shedding the heat that was generated in the compressor section. So what I did is I got a plain old pedestal fan, you know, those 30 centimeters jobbies you pick up from the hardware supermarket for 30 bucks. I put it on flat out and I put it about 2 feet away from it, pointing down onto the fridge. And I ran exactly the same test. Cover on, with the fan and without the fan. And here are the results. Now, the freezer curves are the one you want to watch. So the light orange is with a fan and the orange is without a fan. And as you can see, the freezer without the fan switched off and then wasn't able to dissipate enough heat to actually turn back on again. And it was just below zero here. There was actually some instances where the freezer was at the same temperature as the fridge, surprisingly. Anyway, when we put the fan on, well, now look at that. We're consistently below -5 degrees, and we actually peaked at -8.7 at 7 hours and 50 minutes. So yes, it's confirmed 100%. The fridge cover is stopping the hot air from getting out and away from the fridge, stopping it working efficiently. Well, let's have a look at the current. And there we go. So with the fan, 35.73, and without the fan, 39.04. So that's 9% more battery capacity we used by putting on the cover and having a less efficient fridge. So it chewed through about an extra 10% of our battery with the substandard standard ventilation with the cover on versus the forced ventilation. I'm starting to suffer from buyer's remorse as far as this cover is concerned, or the transit cover, what Engel call it. You pay an extra couple of $100, you chew more battery and you get worse performance. Find me a positive attribute. So what do we think in the end? Well, it turns out using a step-up converter to get a little bit of extra voltage, like when the car is operating, is a worthwhile thing. If you have it a little bit of extra battery capacity, you'll get a substantial increase in performance. Now, if you're not sure how to wire these things up, because sometimes they have limited voltage inputs and things like that, there's a video up there, and what's applicable to wiring one of these up for a Travel Buddy type 12 volt oven, or a Road Chef or a Kick-Ass, will work exactly the same for your refrigerator. Fully filled versus partially filled fridge. Not a lot in it, 3%. Tiny bit of extra performance fully filled, but nothing. Onto the cover. I'm struggling to find a positive attribute for the cover. They cost more for your fridge, they give you worse performance, they go through substantially more battery. And it's because of the ventilation. And we've proven that. Now, admittedly, we didn't test this in high ambient temperatures. 12 degrees was my average temperature for when I was testing. So if you're in the tropics of North Queensland and it's 35 degrees, well, you might get better performance with the cover on. However, your compressor section will be generating more heat to cope with the high ambient temperatures. So maybe it'll make the performance even worse. I don't know. We might check that out this summer. If there's any interest, drop a comment below. Now guys, if you like this video, don't forget to give it the old thumbs up, and if you didn't, by all means, give it a thumbs down. Twice. Thanks guys. We'll see you in the next one. So we chew through about an extra 10% of battery with a cover on with no ventilation or substandard ventilation and forced ventilation with a... Oh, bit windy down here. Windy.